uniform circular motion, that is a UCM. Here, these are some characteristics of the uniform circular motion. First is, uniform circular motion is defined as the motion along the circumference of a circle with a constant speed. This speed is a angular speed. In UCM, the direction of velocity is tangent to the position of a particle. Here, the direction of velocity we have just considered as a linear velocity. So in the diagram, you can see this is a linear velocity which is always tangential to this circular path, and the angular velocity is always remains constant. The direction of velocity goes on changing continuously as the position of a particle changes. The magnitude of this velocity remains same, and the acceleration responsible for this centripetal or the radial acceleration, it is always given by AR is equal to minus omega square R. So here this is a radial acceleration which is always acting towards the center, and this acceleration is responsible for this centripetal acceleration, which is also called as a radial acceleration. For UCM, its magnitude is constant, and therefore it can be written as A is equal to omega square R. If you substitute the value of omega, so we can write that we get the another equation V square upon R. Now if you substitute the value of the V square again over here, so V upon R as a omega, so we can get the another equation for the linear acceleration is nothing but the V into omega. So we can say that the angular velocity is remain constant in UCM, and this is always directed towards the center of a circular motion, that is along the radius, and hence it is also called as a centripetal acceleration. This uniform circular motion is a periodic motion. Why? Because it is always occurs in a same period of time. For example, circular motion of any particle of a fan rotating uniformly. Now let us consider what is a non-uniform circular motion. See some characteristics of it. A non-uniform circular motion is defined as a motion along the circumference of a circle with increasing or decreasing speed. So here whatever the velocity is there, tangential velocity is there or the angular velocity is there, it will either increase or it will decrease. In non-uniform circular motion, the direction of instantaneous velocity is also tangential to the position of a particle. So here we can find out this is a tangential velocity, and it will always goes on changing with respect to time, and it is also always tangential to the circumference of a path, and therefore the acceleration responsible for the centripetal or the radial acceleration is also given with the same formula as in UCM, that is AR is equal to minus omega square into R. Here some quantities have a direction, so they are always shown with a vector sign. For a non-uniform circular motion, its magnitude is not constant, and it is also given by the same formulas, that is omega square R is equal to V square upon R, or it is also written as V into omega. Hence, the angular velocity is not constant. Why? Because the tangential velocity goes on changing. Acceleration responsible for the changing the magnitude of velocity is directed or along or opposite to the velocity. I repeat, the acceleration responsible for the changing the magnitude of velocity is directed along or opposite to the velocity and hence always tangential, and this is called as a tangential acceleration. So AR is a centripetal acceleration which is always towards the center, but the AT I can just take it as they are always tangential to this path. So I can just write down that AT is always tangential to the path. So AT and AR, we can get it the two components of acceleration in a circular motion. As the magnitude of a tangential velocity v changing during the non-uniform circular motion, the corresponding angular velocity omega is also changing at every instant. And due to the angular acceleration, we can write down the value of A is d omega upon dt. In a non-uniform circular motion, the particles are still in the same plane. They are not changing their plane. Hence, the direction of angular acceleration alpha is still along the axis of rotation. For increasing speed, it is along the direction of omega, while in the decreasing speed, it is just opposite to that of omega. So, it is well explained in this diagram. So, in a non-uniform motion, the particles are still in the plane, hence the direction of alpha is still along the axis of the rotation. Suppose this is the axis of rotation, so alpha will be always lying along the axis of rotation. But if it is in an increasing speed, so the direction of alpha and omega, they are remain same, whereas if the speed of a particle decreases, then the direction of alpha is just opposite to that of the direction of angular velocity. So when we switch on the fan or switch off the fan, the speed of a particle of a fan goes on increasing or decreasing for some time. However, their direction are always tangential to the circular trajectory. If the speed increases, in that the direction of alpha lies in the direction of the omega, but when we switch off the fan, the speed of the blades of the fan decreases. That time the direction of alpha is just opposite of that direction of omega. If the angular acceleration alpha is constant and along the axis of rotation, then all angular displacement, angular velocity and angular acceleration will be directed along the axis, that is in the same axis. Let us see the difference between the centripetal force and the centrifugal force which arises during this circular motion. The force provides the radial acceleration in a uniform circular motion is called the centripetal force, whereas the centrifugal force is called as a pseudo force, and this is arises due to the centripetal force in the frame of reference. The centripetal force is a real force acting on a particle performing a circular motion, whereas centrifugal force is a pseudo force in a uniform circular motion but not the imaginary force. In UCM, centripetal force means a resultant of all real forces, and it is given by vector F is equal to minus m omega square into vector I. Whereas in a UCM, centrifugal force means a net pseudo force, and it is given by vector F is equal to plus m omega square into vector I. It is a necessary force for maintaining a circular motion in an inertial frame of reference, and the centrifugal force is an imaginary force in order to take the Newton's law of motion valid in a non-inertial frame of reference. So in a non-inertial frame of reference, we get the centrifugal force, whereas in an inertial frame of reference, we get the centripetal force. Centripetal force acts along the radius of a circle and directed towards the center of a circle, whereas the centrifugal force acts along the radius of a circle but directed away from the center of a circle. Centripetal force does not do any work. Similarly, the centrifugal force also does not do any work. So there are two ways of writing the force equations in a circular motion. The resultant force in a centripetal force is minus m omega square into vector r, or rearrange this equation, we can write m omega square vector r plus resultant of all real forces is equal to 0. So net force acting in a circular motion is always 0.